Good morning. This is Eng Suraj Singh, professional engineer. I was talking to you in the previous file, Building B in English, which are information to general public of the construction. I continue my slides. I am going to slide number 14, which is now here like this. This is slide number 14, which gives you material A, structural, concrete reinforcement, binding wire, soil fill, concrete production, membrane, concrete spaces, plastic covers, blocks, concrete mixtures. I had explained to you about these requirements in the last file. Now I'll go to number 15. Number 15, this is for the materials B. Materials B, which is giving structural. As a concrete, blinding, structural reinforcement, high yield deformed, mild steel, welded wire fabric, binding wire. Concrete, I explained to you, is a very vast material that is cement plus sand plus aggregate plus water plus chemicals plus admixtures, etc., etc. And concrete is mixed by the batching plant, or it is mixed by mixer on site, by the batcher, or it is mixed on small mixers just by volume batching. Actually, preference is it should be mixed by weight batching. Central mixing plants do all works of mixing concrete by computerized system, and everything is well measured and accurately done. Concrete is transferred by the transit mixers to the sites, and concrete is transported to the actual location by the pumping it is called, and the concrete is very high quality, but it is not available everywhere. In India or Bharat, it's available generally in Bombay, and now it's also in Delhi for the metro works and other works, but it's not very widely used in Delhi. In Bombay, it's widely used, or in Middle East countries of Gulf, it is used very much. All works are done even for the small buildings. Concrete pump is used and mixers are used. Transit trucks are used. High technology is used, but in small houses, in public, in private, in Bharat, it's done manually by using small mixers on site and volume batching. Well, that is also not bad if done under good supervision. Then it is blinding concrete. Blinding concrete is the first concrete which is non-structural and is used on the prepared ground, prepared formation level. That is just to remove or eliminate the unevenness of the soil formation. Then it is structural reinforcement. Structural reinforcement is the reinforcement which is designed to support or to provide the resistances to forces or stresses. For example, tension reinforcement, bending moment reinforcement, compression reinforcement, and so many other kinds of shear reinforcement. Many other classes of reinforcement are there, for example, track controls and so many others, you can say, thermal, etc. Then highly deformed. Highly deformed steel means which is having very high strength, for example, 4,600 kilogram per centimeter square or 460 Newton per millimeter square. That strength is very high, but it's not fully utilized. Then mild steel is there. Mild steel is nominal steel which takes only 1,400 kilogram per centimeter square. It is normally generally used for the stirrups or for rings on the beams. It's not used for main bars. Welded wire fabric is a mesh of steel. This mesh, which is 8 mm, 6 mm, depending on the area per meter length. Let us say 6 mm bars, 20 centimeter spacing, or 8 mm bars, 20 centimeter spacing, or 10 mm bars, 20 centimeter spacing both ways, and it is called welded wire fabric, WWF. It's very fabricated. No binding is done on site. And it's binding wire. Binding wire, as I told you before, binding wire is used to keep the bars in position anywhere in the steel reinforcement, in any structure, in any member. Now, in place of welded wire fabric, we can also use ordinary steel, high yield deformed bars, and there's no harm in that. This is the materials B requirement in concrete, and concrete, as I told you, is very, very important. If concrete is done according to specifications and a good supervision, it will last long and it will give very good service to the building. But if it is done like as the laymen do on sites, it won't serve any purpose, and it will act like ordinary material which won't have any strength and will not give the required results. The building won't live long, and concrete produced will not be very durable, and it is harmful for the building. It won't resist earthquake forces, it won't resist fire, etc., etc. So let us go to another slide, that is 16. This material C is structural, soil fill, granular, graded material about 2.5 mm and below 75 mm, concrete protection material, and membrane, concrete protection membrane, bituminous membrane, cold or touch applied material. I explained to you earlier, this fill is very important. Soil fill, this should be graded sand, coarse sand, which should not be plastic material like clay or soil, clay or sand, clay or silt, I'm sorry. Clay and silt are not good material. Small quantity of silt is not bad for the purpose of making it cohesive, but sand, graded sand is very important. Granular fill, you call it. Graded material about 2.5 mm and below 7.5 centimeters or 75 mm. 2.5 to 75 mm is the nominal range, and grading curve lies in between this. If you get this kind of material, it's very good for backfill purpose. The liquid limit shall be less than 35% and plastic index will be less than 6, which are nominal acceptance according to any code in the world. Bituminous membrane, cold or touch applied, is used for the purpose of protection of the concrete, as I told before. Particularly, it is used in the foundations, around the footings, around the step columns, and for retaining walls. This serves a purpose to protect the concrete for long term, for many years, against the intrusion of sulfates, chlorides, and the polluted water that makes mobility in the soil structure below, which is not very clear till now, but it makes it. That is very dangerous because today it may not be there, but after 2 years you will find water is moving below the foundations, which you cannot repairs, but it happens. Let's go to the slide 17. Materials D, structural, concrete grades, M15, M20, M25, M30, M35, M40, M40, and compressive strength. Now, what is this concrete grade? Concrete grade means the property of concrete, compressive strength particularly. When you test a cube of concrete, 150 mm by 150 mm by 150 mm, cast on the day of concrete and tested on 28th day of the concrete after doing well query. This strength is defined as, for example, M25. It gives a strength of 25 Newton per millimeter square. This is compressive strength on 28th day of casting of concrete. Similarly, 35, 30, 40, these are all similar kinds of strength. M50 and M20 are considered nominal concretes, which are generally used for the blinding purpose or for lean concrete purpose, but concrete grade M25, 30, M35, M40 Newton per millimeter square are used for structural purposes. Nowadays, particularly M35, M40 are generally used for structural concretes. These are the compressive strengths for the concrete, but this is not the final answer for the concrete acceptance. There are so many other tests, but this is a direct test. Compressive strength it is. Characteristic compressive strength on 28th day, and this defines that the concrete is okay, but it doesn't specify that the same strength on-site concrete gets. That is another test. If it required is done when it fails. But generally, on 7th day we test, and proportionately on 7th day 65 to 70% strength we get in the concrete, that is accepted, and on 28th we get minimum the specified grade. It can be more, but should not be very much higher than specified. So let us go to other slide, and that is 18. Slide 18. It gives you material E. Materials E structural again. Concrete slump. Now, a concrete slump. You see, what is concrete slump? Concrete, when you mix on site or you get from the batch plant, you test on site by pouring the concrete into an instrument that is called equipment type instrument that is called cone. It's cone 30 centimeter high, and you have to fill the concrete 3 times into this. By compaction, each layer you have to compact, and then you have to take the cone off vertically, and you'll find a fall from the top level of cone line to where the concrete goes. That vertical fall is called slump, and that slump it should be up to 75 mm for concrete that is to be poured by the crane. It should be up to 200 mm for pouring the concrete that should be transported by a pump, and it can be 50 mm also for very massive works. For example, you have to construct a road, or you have to construct a foundation manually. You have to pour. You don't have to use any machine like crane to pump. It can be accepted up to 50 mm also. Concrete temperature should not be more than 32 degrees Celsius. That is very important, because higher the temperature, lower the strength of the concrete, setting problems are there, crack formation is there. In less slump and less temperature, it's nice. You will not find immediate cracks or shrinkage cracks. Then we will go to slide number 19. In 19, we are seeing that